Now, I do want to say that so we're getting close to the end of the first term, and although we have a little bit of time, it's not really that much, and I think every day counts. And I want to say that I'm really grateful that you guys take the time out to come to hear me on a Sunday morning. But I don't think that I can solve every single one of your problems unless you go home and you actually review the material you have and you really think about it. It's a little bit like, if I am a music teacher and you are learning an instrument, so every week you come to me for half an hour and you just play for that half an hour. Okay? Are you going to become better? I don't think so. And this is the same. So in other words, please don't think that just coming here for a couple of hours is enough. It's a start, and I hope that it will be as useful as we can make it. But I think in the end, because the material is interesting, but it is quite heavy, and it requires some thinking and digestion. So I don't blame you if sometimes you are a little bit lost, which is why we provide other alternative media, YouTube and so on, so you can go home and review it in your own time. Okay. Now let me just continue regarding average delta. So if you know what this average delta business is all about, which I try to outline here, you have an option. You just traded an option. Spot is 50, strike is 50. You know the original delta and the old delta and the old gamma. So now the stock price has moved to somewhere else, and you only know the change in the stock price or the difference. And I ask you to figure out what is the new option price. The way to do that is, first, you find out what is the new delta, step 1. Step 2, you find out what is the average delta, which is the old delta plus the new delta divided by 2. And from that, you actually can find out what is the change of the option price here. And not only that, you can see right away, if you use the old delta, well, you can see that the change of the option price has 2 components. Okay, so the first component is this one here. So if we call that Y, okay, the second component is this one, X. So if the whole thing is Z is the total change in option price, so Z is equal to X plus Y. Now what is Y, first of all? Y is the change brought about simply by looking at the old delta, because it's a linear, okay? So the old delta would predict that the option price will change by Y. We know that's not enough, okay? So getting back to an earlier point I told you in the first hour, option trading, option pricing, option book management is all about hedging a nonlinear payoff with a linear tool. Okay? So a lot of the theory that you see, actually comes from that very, very simple observation. Okay? And the theory is solid, okay, which I'm going to show you in a minute. Is everyone okay with that? Yeah? I think it's good if you can try and think of it that way, okay? Now, so let me show you a little bit. So here we say that we use the concept of an average delta, okay? And I have made four points here, okay? So the gamma revenue depends on the change in option price, O delta, and change in share price. Of course it does. Well, okay, remember, okay, take a note of this. So gamma revenue depends on change in option price, O delta, and change in share price. Why is that? Well, gamma revenue is little x here, this bit here, okay? Now, this little bit here is the change in option price, Z, minus Y here. Now, what is Y? Y can be calculated if you know the O delta. Let me use another color. If you know the O delta, is this a highlighter? No. If you know the O delta, and you know the change in the stock price, in other words, you have this green triangle here, okay? So that little bullet point is based on that observation. And then maybe you're wondering, all right, well, then how do I figure out what is the change in option price? Well, change in option price depends on average delta and change in share price. I just showed you before the break, okay? And then you're wondering, well, how do I get average delta? Average delta depends on O delta, the initial gamma, and change in share price, okay? Now, last point, change in share price depends on volatility and initial price, okay? Now, this is the point that I think I want to get into now. So 1, 2, 3, 4. So from here, you get here, and then from average delta, you go to 0.3, and change in share price. So one step at a time. You get what I'm saying? Yeah? And now, although averaging the delta looks like it makes sense, can we actually apply a little bit of theory to it? Well, actually, you can think of it like this, okay? So what I'll let you just read that briefly, okay? So the way I try to show you this is kind of in reverse. I'll show you the result first, and then I'll show you the theory behind it in the next page. Okay? So we are saying that averaging delta actually works. Now, if you average the delta, what it means is, here is the old delta. Here's the old delta, okay? Now, how do you calculate the new delta? Now, this is something that you need to know. The new delta is just the old delta plus the gamma times the change in the share price. Okay, so if you know just a little bit of calculus, so you know that gamma is just the speed of the change of your delta. So it's delta with respect to price, okay? So if you have here gamma times a change of price, so that would be equal to, so gamma times a change of stock price is just the d delta ds times ds. So in the end, you get that little change in delta, which is exactly what you want. Okay, going from 50 to 54, for example. Remember here? Okay, that's exactly what that is. You can add that. The reason is simple, because the stock price change is only $1. Okay, if the stock price change was, let's say, 50 cents, what would be the new delta? It's not 54, right? It will be 52. 4 gamma times a half. Okay. Now, so if you know that, because this is what we claim, that you add the old delta and the new delta, so you have an average. This is the average delta. Okay. Multiply by the change in stock price. And now, if you are, let's say you are long a call, you're long a call and you are short the stock, and when prices go up, you will have a loss on your short, which is equal to this one. Okay, so you are, this is the delta. So you are short a delta amount of stock, and the price changes by this much. So this is the loss from your hedge. So your total portfolio, your delta neutral portfolio, would be whatever you gain from your option, which is this part, minus whatever you lose in your hedge. Now, this is actually the formula representation of, see if I can use another color. This one. It's the representation of this part here, okay? That formula is trying to tell you how you can determine this part, this little x, okay? And where was I? Now, if you simplify this, you can actually multiply it out and simplify it, and you will find this formula actually will collapse to a half gamma ds squared. Now, if you go into the final exam and you remember nothing else, okay? Please try to remember this one. Am I quite clear? Okay. You simplify that, you will get half gamma ds squared. Now, what that means, this allows, and this is sometimes called gamma revenue, okay? This allows you to calculate that little bit of profit, that little x, when you have an option, and it doesn't have to be a call option, okay? But let's just say call option. When you are long a call and you have delta hedged it, and the stock price moves by a little bit, so you have a loss on your hedge, but you have a far bigger gain on your option. So there's always a gap, which is that little red bit. How much money have you made? How much? Okay. First of all, it's called gamma revenue. And second, how do you determine that? Well, it's that simple formula. Okay. A half gamma ds squared. Gamma is the initial gamma. It's the gamma naught. Okay. Now, it's actually a very simple formula, which, as I said, came from using the average delta. Okay. Now, I haven't actually proved to you that this works. So all I'm doing is I'm saying if you use that concept of average delta, you do end up getting the gamma revenue, which looks quite elegant and simple. Okay, but can we go a bit further? Well, you can, and I invite you, for example, to have a look at the book by John Howe regarding option hedging. And if you look at the book by Howe, in chapter 13 or 14, he talks about exactly the same thing. He talks about if you had a portfolio where you are long an option and you are short some stocks as a hedge, okay? And you call that portfolio value, you call it pi. The change in that portfolio's value over time is this equation in here. Now, you can find that in Howe. I'll leave it in your lecture, look it up. Chapter 13 or 14. So, let me repeat. If you have a portfolio where you are long some stock, long some options, and you are delta hedge, so you are delta neutral, then the change of your portfolio value is equal to this expression over here. Now, you might wonder, what is this one? First of all, if you go to Howe, there's a derivation which isn't that hard to follow. He does it quite well. So this is, now, you look carefully, okay, at this. There are two terms here. Now, F here stands for the derivative price. Okay, now dF by dt is just the time decay. Okay? So how the price of your derivative will change with respect to time. Now here, a half d2f squared. What is d2f squared? If f is gamma, right? Thank you very much. This is gamma. So it's actually a half gamma sigma square S squared. Okay? Now, ladies and gentlemen, here is where there is a connection. Okay? On the right-hand side is what option price in theory predicts should happen. Okay? Now, what is this formula saying? Okay? So math is very elegant sometimes. With just a few symbols here, they tell you so much. So the change in the value of a delta hedge portfolio should be the time decay minus the half gamma sigma squared S squared. Now, in other words, this is what I call the ex ante. It's ante. Okay. Right hand side is ex ante. Do you know the difference between ex ante is before you know the outcome? Okay. So I mixed that up. So before you know the outcome, option theory says whatever is the time decay, it should be equal to a half gamma times sigma squared S squared. And the actual profit that you earn is equal to a half gamma ds squared. And now, it will be quite obvious to you that if your stock price change, the ds of the ds square on the left hand side, if that was equal to sigma times s, okay, let's just say it is. So let me give you an example. Okay, so if your stock price now is 100, and let's say your sigma is 1%, And if your stock price moves by, let's say, $1, okay, then the actual gamma revenue that you earn would be a half gamma times the square of 1, because 1% of 100 is 1, okay? Now that's the actual revenue you will earn, okay? Now the theory would have predicted that the change of your portfolio value would be whatever the theta is minus a half times gamma times the sigma, which is 1%, okay? 1% times 100, okay? Now this is what option theory tells you to expect. And what really happens, and of course, now if these two, you have to understand, if these two are the same, then you actually don't make any money. And that's the whole point about option pricing, is if you buy, let me put it another way, if you buy an option, okay, if you buy an option, there are two very important things happening. One, from one day to the next, if the market remains completely still, okay, your option will lose value, okay. Now how much? Well, you can determine that using theta, okay. So your option will lose value, first of all, if it does not move at all, okay. However, if it does move, okay, in the scenario where you have delta hedged your portfolio, you will gain a little bit, which is known as gamma revenue. Now, how much are you expected to earn on a day-to-day basis is predicted by the second half of this formula here, okay? And therefore, if the movement of the stock gives you a gain in gamma revenue, which is exactly offset by the time decay, you end up, you don't make any money and you don't lose any money, okay? Now that is probably the most important insight, which really ties everything together for this course, okay? Is everyone okay with that? I don't feel I've explained it too well. Is everyone okay? If you're not okay, do this. Yeah, no, go on. Yeah.
Why both of them are the same sign? I mean, you have to connect to the number.
The same sign.
Yeah, they're all negative.
Okay, thank you for asking me that. He's asking why are these the same sign? Actually, now df by dt itself is a negative parameter because time decay is just a way of saying what is the change of value from one day to the next. Now the value is not increasing. If the value was increasing, then that value will be positive. But because the value is decreasing, df by dt is actually negative. So negative actually gives you a positive value. Okay, so this will be this is a positive value. In fact, this looks like it's from the point of view of someone who is short an option, maybe. So short an option, so you gain on theta, but you have a burden here, and the predicted burden is a half gamma sigma square s square. Okay, it's a little bit like, you know, in your investment and portfolio analysis, you just take the CAPM, for example, okay? So everyone says the excess return of a stock should be, according to the model, okay, should be beta times the excess return of the market. Now, is it? If it is, okay, that means that whatever actually happens in the market, this is how you calculate it, okay, is the same as what the model predicts. If it is not, then there is some kind of alpha in it. Okay, it's a similar concept. Are you guys okay with that? Yeah?
So can you understand this in this way? Just like when the time decayed, it just like when you say from the last class, it's like a balloon, and when it decayed, the slope become more deeper, so the gamma ray will so become more bigger, and the time decay would offset this change fast. The rates of the change, which will generate in the gamma ray.
I think you might be thinking of something different. I know what you're saying. There are changes to okay, here is the now, one thing that I can draw to your attention, let me try to unravel your question and give you some of my response. Yeah. One thing that is consistent between longer term options and shorter term options is that when you look at these two graphs, okay, the one for theta and the one for gamma, okay, what you can see is that the theta for short-term options are higher than theta for long-term options. You can see that, right? So for the theta, the blue one, the blue line, it really, at least for options that are at the money, okay? And likewise, the gamma for short-term options are higher than gamma for long-term options. Now, to very simply verify that, all I got to do is to come here. So I price an option for, let's say, 90 days. Okay, this is a very simple option. And you can see that there are gamma values, 0.032, and theta. Can you see theta is negative? Yeah? So negative 0.027. Now, what I am saying to you is the moment I change that, let's say from 90 days to, let's say, 15 days, okay, the gamma value will shoot up, and so will theta. But theta will become more negative, okay, so you watch. So 0.032 and minus 0.027. Okay, so now gamma is almost double, and theta also is a lot higher. Can you see that? Yeah. Oh, I can't draw on this. The theta is now minus 0.067. Okay. Now this is actually consistent with the graph I showed you. What does it actually mean? What does it mean when okay, let me go back to 90 days. Okay, let me go back to 90 days. So here you have an option underlying 100, exercise price 100, 93 months, 90 days to maturity. Now theta is 0.027, And if I just change this 90 to 89, you should actually see the price of the option drop by 2.7 cents. I think that's how they, you see, it goes from 4.949 to 4.922. Did you see that? Yeah? Now, please remember this theta parameter is not constant. It accelerates near the end. So let's say now from one day to the next, your option will change or will lose value by about 3 cents. You can see immediately that 3 cents, if you multiply that by 90 days, is what? $2.70. But your price is $4.90. Okay, so it has to pick up speed. So when you have only 5 days left, let's say, okay, and you hit calculate. Now watch the theta parameter, okay? Now every day you are losing 11 cents or 12 cents, okay? If I change that to 3, now only 3 days left. Even higher. Only 1 day left. That's when it's at the highest. Okay? Are you with me? All right. Now, let me try and tie it all together. So there are some now there are some simple rules that I think will help you do some of those questions that have come up. And the first thing is I want to talk about delta, okay, and what it means if you are long delta. If you are long delta, it's very simple. If you are overall long delta, your portfolio is long delta, it means when the market goes up, you're happy. Okay? So you want the market to go up. And so that does not only apply to when you are long call, because you are long delta, but if you are short the put, if you sold a put to someone, you don't want the market to go down, you want it to go up, so you are also long delta. So you can actually flip that. If you are short call or long put, what deltas do you have? You're short delta, thank you. Yeah, you're short delta. Okay? And now for gamma, when markets become very choppy, very volatile, okay? If you are long gamma, that is when you are very, very happy. And I'm talking about if you are, let's say you are long gamma, all else being equal. In other words, if you are, and I'm not even thinking of what delta, let's say you are delta neutral, okay? If you are long gamma and you are delta neutral, and the market is going up and down, and it goes here, of course, the further it goes, the happier you are. You don't care which direction it goes, because whichever way you look at it, you are making money. And that is happening because if you are long a call, then you make money faster than you lose on your hedge, or you lose money down here slower than you gain on your hedge. So down here, you also, don't forget, here you also make gamma revenue, okay? So you don't really care which direction it goes, you just want it to go somewhere, as far as possible, okay? Now that's the key point to remember. And for Vega, of course, if you are long, all of these are from the point of view of being long, so to be long, on the top left-hand corner. If you are long Vega and the market is turbulent, then you are also happy with that, okay? So the delta rule that I have here is when an option is in the money, the delta of a short-term option is higher than the delta of a long-term option. But when it's out of the money, the delta of a short-term option is less than the delta of a long-term option. Okay, now this is applicable to puts and calls, and you don't need to memorize that. And I will show you how to remember it. No, not how to figure it out. Okay, the rules for gamma. When an option is at the money, the gamma of short-term options are higher than gamma of long-term options. You actually saw that in the graphs earlier, okay? But when it's out of the money, the opposite is true. So there was a point when they actually cross over, as you remember. Okay? Now, some of these rules here are no more than just written explanation of those graphs. Okay, just trying to put them in words. Okay. Now theta, likewise. So the short-term theta is higher than the long-term theta for at-the-money options. Okay, but for out-of-the-money options, the opposite is true. Again, if you go back to those graphs, you will see that this actually makes sense. And the last thing is this formula at the bottom, I think should help you tie the whole thing together. So this is what option pricing theory actually predicts, which is if you have, let me write it out. If you have pi is a portfolio where, let's say you are long, it doesn't have to be call, by the way, okay? And then you are short some stocks. So here's your option, here's your hedge, here's your hedge. So option theory will say that the change of the value of that portfolio is just the change of your option price over time minus a half times gamma times sigma times the stock price over time. Okay, now the point to remember here is if you invest in an option and you don't hedge it, so you do not have any market risk, okay, you really shouldn't in the end, ultimately, you really shouldn't earn anything because you are not taking any risk. If it was possible for this formula to give you something, if it was possible for delta pi to change value from one day to the next, we don't need to go to work, okay? You buy an option and delta hedge it. So again, this arbitrage argument comes into place, which is in a world where markets are efficient, you should expect that delta pi is on average equal to 0. Now that is another way of saying that the time decay, not time day, time decay, should be equal to the, what should I say, the ex ante or expected gamma revenue. Okay, now I cannot emphasize how important this point is. So like what I was saying you earlier, I asked you to remember a half gamma ds squared, and I said this will enable you to answer a lot of questions. Yeah, well, fine, okay, but this actually explains how the whole thing hangs together. So in a world free of arbitrage, option theory predicts that from one day to the next, you are what we call, well, to use Tobias language, when you are paying theta, okay, what you pay, in other words, this amount here, the 26 cents that you pay, okay, you only have 1 day, so it's a bit of an extreme. This 26 cents that you are paying, okay, should be equal to the expected market movement. Now, what do we mean the expected market movement? Well, as you see, here there are 3 parameters here. There's gamma, which you can calculate. There's a stock price, which you can observe, okay? Now, the sigma, this is an interesting one, okay? This is something, sigma is a, as you know, is the implied volatility, is a projection or market prediction of how volatile the market will be, okay? So in other words, the more volatile the market, or the more volatile people think the market will be, okay, the higher the option price, number one. So when theta when sigma goes up, okay, the option price goes up, and the gamma revenue will go up. Gamma revenue will go up, and then theta will go up as a result. Okay, so that's how it all hangs together, and the market is priced fairly if what the model predicts, sigma s, okay, in fact is the actual change in share price that you see exposed. Okay? Everyone is okay with that? It's all quite neat, and the theory is solid. Is everyone okay? Yeah? Now, this you really need to understand. Otherwise, you will find, much of this course a bit of a struggle. But once you understand, everything just follows. Okay. Now here I have another slide where I explain the thing about PutCall Parity. When we said last time that C minus P is F minus X, this F, as I said before, is not really the actual forward. This X, this F is the spot plus the interest on the strike. Now that is not the forward, okay? But don't let that worry you. This formula actually is valid. It is correct, okay? It's just that I wouldn't call this item here the forward. So I think last time we already explained that, okay? Is everyone okay so far? I have actually received quite a few questions from you, those of you who took the trouble to update the Google document. I thank you very much for that. It may be better if we cover those questions either next time or possibly in a video format, because people are asking questions on, lecture 2 and then lecture 4 and lecture 7 and lecture 5, back and forth. And some of the questions would need me to explain in quite some detail. So I might do that in a video format just to save time here. Okay. Now, likewise, those question sets, quite possibly. Okay. But I promise you I will do it. Okay. There are just a couple more things that I want to look into, and then I'm going to let you go. Okay. The first one is regarding this idea on forward volatility, and the second one is the risk reversal. Okay. And this one is, I think it came from lecture 5. And this one came from also lecture 5, page 53. Was it lecture 6? 5 or 6? We'll figure it out. Now, do you remember in lecture 5, we talked about, I think the idea is called bootstrapping. If you feel dizzy, just close your eyes. How do I scroll forward? Oh, here. What page did I say? Page 42. Okay, now here, do you remember these slides? Because some of you are asking me, and in the past students often had problems. Did you go through that in the lecture? So you guys are okay with the idea behind? If it's not okay, do this. Okay. Okay. Some people say it's not okay. Now, the idea is as follows. Let me just explain to you the idea. Okay. The idea is this. You know how in interest rates, if you have a 3-month interest rate, and if you have a 6-month interest rate, it is then possible for you to work out what is the expected 3-month interest rate from month 3 to month 6. This is known as a forward rate. You all know that concept, right? It's just a break-even calculation. if the market thinks for 6 months I should charge you that, and the market thinks for 3 months I should charge you that, surely the market has an opinion about what this value here should be, and is known as the forward interest rate. Now, in volatility, there is a similar concept. There's a similar concept, except that, okay, first of all, how do you work it out? How? Okay, is if you use variance and you have, let's just take a look at these two, okay, options A and B. And let's say they are of the same company or same index, and the only difference is the time to maturity. Okay. Now, if one of them is quoted at a vol of 24 and the other is quoted at a vol of 36, and one is 1 month and one is 2 months, okay, what does that mean? So for 1 month, here's the 1 month, and here's a 2 month. 2 month. So 1 month has a vol of 24%, and 2 month has a vol of 36. Now, just like the interest rate example that I was telling you, it is possible to work out what this should be. Okay, this part here. Let me draw it another way. Okay, so this is volatility. Okay, this is 1 month and 2 months. So 1 month is 24. And 2 months is 36. Then the 1 month vol in 1 month's time should be somewhere in the middle. Okay, don't just take the average. It's not that simple. And how you work that out, how, is given by the formula that you now see, this one, okay, the variance formula. So you can work out what this should be. Okay. Everyone is okay with that? Okay? Is everyone okay so far? Okay, now, so this is the break even, or you can say is the forward volatility. Okay? Now, what is so interesting about that? The interesting thing is, at least in the example given in the lecture, so let me redraw that diagram. So 1 month and 2 months, and so 1 month is 24, and 2 months is 36. Now, let's say you work out that the forward vol of 1 month in 1 month's time is somewhere here. Again, I have to emphasize, you don't just take the average. Okay, it is some kind of average, but you don't just add them up and divide by 2. Okay, it's not that simple. But let's say you work this out and it's 27. Let's just say it is, okay? And then what we're saying is no, actually it has to be higher than, yeah, it has to be higher than 36, okay? Because your 2 month needs to be some kind of averaging value between the 1 month starting now and the 1 month starting in 1 month. So that one will be here somewhere. Okay? Hold on a sec. So that would be the forward vol, the forward volatility, okay, or 1 month vol in 1 month's time. Now, I give you another scenario, which I think was the one related to you in the lecture. Let's say the volatility of 1 month is actually higher than the volatility of the 2 month. So let's say the 1 month vol was 30 and the 2 month vol is 25. Okay. So I kept referring to the slides, but the actual example is the opposite. Now, what does that mean? So that means 1 month, the vol is here, 30, and the 2 month vol is 25. Okay. Now I asked you if this 2 month is supposed to be a combination of the 1 month starting now and the 1 month starting in 1 month, then that other one, the forward one, has to be down here somewhere, right? So let's say it's 17. Let's just say it is. Okay. We can, you can calculate that quite precisely. Okay. But let's say this is the forward vol. The argument goes, first of all, why is this one up here when the 2 month vol is lower? Okay, now imagine that there is some kind of earning announcement within the next 30 days, which will cause the stock price to fluctuate up and down. Okay, now that can be a cause for the near-term volatility to be higher. And the idea is, in 1 month's time, now that would affect the volatility from 0 to 1 month, but it will also affect the volatility from 0 to 2 months, because that also contains month number 1. Okay. However, it will not, that earning announcement, it will not affect the volatility from month 1 to month 2, because that's got nothing to do with it. Okay. So the idea is, well, if there is no announcement for this company, okay, then the normal volatility in a period of stability and quiet and calm should be 17. Okay. Then our idea is that should also apply to month 1. It should also be 17, except for that 1 day when there is an earnings announcement, when the volatility for that day might be, let's say, 40. Let's just say 40, okay? 40%, okay? So because it's always 17, 17, 17, but for 1 day it's 40, the end result is that 1 day volatility will drag the whole thing up and then lift it up to have an overall 1 month volatility of 30%. And if you can figure out whether it's 40 or 45 or 42 or 47, okay, that is the market's view of how much the price should fluctuate, or how volatile they think the earnings will be. Okay. Are you with me so far? Yeah, it's okay? Yeah, so I just want to reinforce that point. I think I did some I'll share with you my experience. In one case, I did some calculations for Google, and because it had an earnings announcement coming up, and so you can work out by looking at the forward vol and then backdating it and saying that this is normally the vol you would expect, but because of that one day, which will be different, okay, and then you can try and figure out if there's a 30-day vol, and then you think of the vol of the other 29 days. So for that one day, you can figure out what kind of price movement. And I calculated that the price of Google would probably move by about 5%, up or down. So at the time, I think it was trading around $600 per share, which means the market expects that the share price will either go to 630 or maybe 570 on that day. And you know what? It did exactly that. Okay. So sometimes these things are quite useful. I think it went up to 630. It went up 5%. Okay. So the option market is sometimes they tell you interesting things. Okay. Now the only other thing I want to mention here is regarding a risk reversal, and I think this is lecture 5, page 53. Lecture 5. This is lecture 5. Yes. So if you are, so first of all, do you all know what a risk reversal is? Do you know? After this, I'll let you go, okay? Because I have to go too. Do you know what a risk reversal is? Standard question, especially for FX candidates, okay? Risk reversal. So let's say the spot price is now 100. Let's just say it is 100. Okay. A risk reversal is when you long a call, let's say at 105, and you short a put at 95. So your payoff will look like this. So here nothing happens. Between 95 and 105, nothing happens. But if it goes below 95, you start to have a loss. If it goes above 105, you have a gain. Okay? Now, that's a risk reversal. Risk reversal. It's called a risk reversal, I think, because your risk changes here from a loss into an option gain. But then, if you simply buy the underlying, that also happens. That's the dotted line I'm drawing now. Okay, you're just delaying that process of a gain or a loss. Okay, why would you trade a risk? Why would you trade a risk reversal? Okay, you know the thing about learning about finance is, okay, now I've told you what a risk reversal is, and you're thinking, oh, isn't that interesting? Now I know. Okay, yeah, but what is it for? To add to global warming? No, there's a purpose behind it. The reason people, this is especially, you can trade this, of course, in any asset class, but it's most often applied in foreign exchange and sometimes in equity. Okay, so you buy an option, you buy an out of the money call, and you sell out of the money put. And can you think of, if you're in an interview and first of all, I ask you, oh, what is a risk reversal? And you're thinking, oh, yes, I got this, okay, I know. And then I ask you, okay, why would you trade that? Imagine I'm the client You are a sales guy. Why do you want to sell this idea to me? Yes, Annabelle. Yeah. Forwards.
Verify what next currency.
You can trade this based on a forward price. Yes, you can. But then you don't need a risk reversal if you want to trade the forward. Actually, the reason depends on the volatility of the portfolio. Decrease. Yes, you are right. He says you decrease the volatility of your portfolio, which is actually it's in the right direction. Now, if you have a structure if you don't have a structure like this, let's say you want to trade the Nikkei 225 and you are rock solid confident, or okay, you are not rock solid confident that you have the correct market timing, but you are confident that it will go up, okay? But you just don't know whether now is a good time to enter. So if you just buy the physical market, then the moment it goes up or down, you immediately can have a loss, and maybe you don't sleep well, okay? You still want to take a position. You just don't know now is the best time, but you are firmly convinced it will go up, okay? So that's the moment when you will trade a risk reversal. So when there's a little bit downside, you don't worry so much. And when the market starts to go up, you don't have a gain immediately, but that doesn't bother you because you think long term is going to do this, okay? Now, of course, it has to be based on some kind of personal belief you have. If you're wrong, then all bets are off, okay? So you have to be right, but this is more like an execution technique that even if you are right, you can try to avoid the interim turbulence, okay? So clients sometimes like to trade that. Now, but the point is, if you look at the slides, the lecture slides, so first of all, if you buy a call, let's say the spot price is 100, so you long a call at 105, you short a put at 95, so you're doing this, and the market is here. Long call, short put. So your gamma and your theta and vega positions should be approximately 0. If these two are, out of the money by, the same amount, they might not be exactly 0, okay? Sometimes people think that's a market signal when they are not exactly 0. The risk reversal is telling you something about what the market is thinking. But let's say they are 0, okay? Then as the market goes down, starts to go down, you will be short gamma, and the time decay works in your favor. But if volatility goes up, it will hurt your position. Now, I will leave it to you to figure out why these things are the way they are. And then if the market goes up, you are long gamma, and you are paying theta, and you are long vega. That means if volatility goes up, you are happy, okay? Now, it's a good exercise if you ask yourself why, okay? But what I want to focus on before I let you go is this sentence here. I would much rather to be the other way round. What is the author trying to say there? Why? Okay, that's my focus. You know what I mean? So what is happening right now is that you have a risk reversal, number one, okay? So first, you have a risk reversal. And two, if market goes down, MKT, market goes down, you become short gamma and you become short vega, which means that if the market becomes volatile, it will hurt you, okay? So when the market is volatile, you don't want to be short gamma. You want to be long gamma. And again, it goes back. You see, it's all related. Why is it good to be long gamma? Long gamma means you get to make this profit here. And you want to make the profit not here. You want to be right here, if possible, okay? The more volatile, the better. So when markets are volatile, you want to be long gamma. Now, here the connection is this. Here you are short gamma and short vega when market goes down. Now, empirically, in the real world of trading, the market doesn't sort of do this and then do this and up and down so uniform, in such a uniform manner. Okay, so what you often see, in fact, almost every time, is markets go up little by little, and when it goes down, it just does that. Okay, so therefore, if you have a position like the risk reversal, and the market goes down, and right at that moment, you are short gamma and you are short vega. When volatility goes up, that's the last thing you want. And likewise, when markets are going up, you are long vega, so you want volatility to go up. But when markets are going up, normally option volatility is going the other way. Okay, so that's the thinking behind that statement there. Okay, now. I would recommend that after you go home, if you like to review these slides, especially this one, and maybe have a look at what I said about average delta and how it relates to how, and the relationship between a half gamma ds square and a half gamma sigma s all square. Now this I consider to be the heart of this course. And I will look at your questions, including any questions you may have after today and all the questions you have sent to me. Now we also looked at these simple rules, which I have written here. And I promise that in less than 10 days, I will be able to show you why it is like this, okay? So you don't need to remember these things, but first I lay them out. And next week, we'll start going into early exercise and all that stuff, okay? All right, so I'm going to let you go, and I wish you a very happy Sunday afternoon, and thank you again for coming. Okay. I appreciate that.